Neptune is the 8th and farthest planet from the Sun and the 4th largest in the solar system. Because it's so far out, it's not visible to the naked eye. Named after the Roman god of the sea, it's also known as the Blue Giant because of its vivid color. Neptune is so far from the Sun that its high noon would look like dim twilight to us. The light we see on Earth is about 900 times as bright as sunlight on Neptune. Like the rest of the solar system, Neptune formed about 4.5 billion years ago. Along with Uranus, it probably formed closer to the Sun before moving to the outer solar system about 4 billion years ago. Only a single mission has flown by Neptune, and that was Voyager 2 in 1989. This is one of those things that really makes you realize how big space is, because Voyager 2 visited Uranus in 1986 and then took 3 entire years to reach Neptune. Today, there are still many mysteries about Neptune, such as why its winds are so fast and why its magnetic field is so unusual. The planet is interesting not just because it's in our own solar system, but because studying it can help us learn more about exoplanets similar to it. Come along with me as we explore the most distant known planet. After Uranus was discovered and added to the roster of planets in the solar system, astronomers observed it and they eventually came to notice some irregularities in its orbit. These irregularities couldn't be explained by Newton's law of universal gravitation. An alternative explanation could explain it, however: a more distant, undiscovered planet. Almost simultaneously, 2 different astronomers independently came up with nearly identical mathematical predictions about Neptune's existence. These were French astronomer Urbain Jean-Joseph Leverrier and English astronomer John Couch Adams. Leverrier then informed his colleague, German astronomer Johann Gottfried Galle, about his calculations. Galle and his assistant Heinrich d'Arrest confirmed the predictions by observing and identifying Neptune through a telescope at the Berlin Observatory. The planet was found just about a degree away from its predicted location, so Leverrier's calculations were extremely accurate. Neptune was found on the night of September 23rd and 24th, 1846. In retrospect, it was discovered that several astronomers, including the famous Galileo Galilei, noticed Neptune and observed it, but they didn't recognize it as a planet. The same thing happened with Uranus. Although astronomers saw both planets, they're so far away and move so slowly that no one recognized them as planets. Like all the other planets, and as suggested by Leverrier, the new planet was given a name from Greek and Roman mythology, and thus Neptune became named after the Roman god of the sea. Neptune orbits at an average distance of 2.8 billion miles from the Sun. At this distance, sunlight takes about 4 hours to reach the planet. 1 day on Neptune, or the time it takes to rotate once, is about 16 hours. It makes a complete orbit around the Sun in around 165 Earth years. In 2011, Neptune completed its first orbit since its discovery. Sometimes Neptune is even further out from the Sun than the dwarf planet Pluto. Pluto's highly eccentric and oval-shaped orbit brings it inside of Neptune's orbit for a period of about 20 years every 248 years. This happened most recently from 1979 to 1999. Despite crossing one another's orbits though, Pluto and Neptune can never collide. For every 3 times Neptune orbits, Pluto orbits twice, and through this repeating pattern, the two will never make a close approach. Neptune's axis of rotation is tilted by about 28 degrees with respect to the plane of its orbit around the Sun. This is similar to the tilts of both Mars and Earth. Because of the tilt, Neptune experiences seasons, each one over 40 years long. With an equatorial diameter of 30,775 miles, Neptune is about 4 times wider than Earth. The diameter from pole to pole is a bit smaller though, because Neptune has a spheroid shape, which means it bulges at the equator. Neptune is more than 17 times the mass of Earth and nearly 58 times Earth's volume. Neptune is one of the solar system's 2 ice giants, with the other being Uranus. These 2 planets are called ice giants to emphasize the fundamental difference in bulk composition from the solar system's other 2 giants, the gas giants Jupiter and Saturn. The name ice giant comes from the materials that Uranus and Neptune are made of. They're both primarily composed of ammonia, methane, and water. Because these materials condense and freeze rather than remaining gaseous in the cold temperatures of the solar system, they're called ices, and so planets rich in them are ice giants. Neptune is the densest of all the giant planets. Its bulk composition is roughly only about 10 to 20% hydrogen and helium. 80% or more of its mass is made up of a hot, dense fluid of icy materials like water, ammonia, and methane. All this sits above a small, rocky core of iron and magnesium silicate. Underneath Neptune's cold clouds could be an ocean of super hot water. This water wouldn't boil away because the intense pressure keeps it locked in place. Neptune has no solid surface. The atmosphere extends to great depths to eventually merge into water and the other melted ices. Neptune Neptune's atmosphere is made up mostly of hydrogen and helium, but with a little bit of methane. This is similar to the makeup of the atmosphere of Uranus. The planet's blue color comes from the methane, which absorbs red wavelengths of light and reflects blue ones back out. Speaking of Neptune's color, you might envision it as more intense than it actually is. Many of the images of the planet, most coming from the Voyager 2 flyby in 1989, show it as a very deep blue color. This is because the Voyager team tweaked the images to better reveal Neptune's clouds and other features. In 2024, researchers reprocessed the images to show that Neptune is far more similar in color to Uranus than many people probably think. The observable atmosphere of Neptune is more than 80% hydrogen, about 15% helium, a small amount of methane, and trace amounts of other molecules like ethane, acetylene, and several other hydrocarbons. Neptune is known as the solar system's windiest planet. Despite its great distance and low energy input from the sun, winds on Neptune can be 3 times stronger than Jupiter's and 9 times stronger than Earth's. Neptune's winds have been known to reach up to 1,500 miles per hour, which makes them the fastest winds recorded in the solar system. These speeds were linked with a large dark storm tracked by Voyager 2 in Neptune's southern hemisphere. The storm was dubbed the Great Dark Spot, and it was large enough to contain the entire Earth. By 1994, the Hubble Space Telescope revealed that the Great Dark Spot had disappeared, but another one soon formed. In the years since, more large storms have been observed. In the Voyager image, underneath the Great Dark Spot is a bright cloud feature called the Scooter. This name comes from how it sped around Neptune faster than the dark spot. The south of the Scooter is a smaller but similar storm named Dark Spot 2. Because of the high temperatures and pressures on Neptune and Uranus, scientists believe compressed carbon in the form of diamonds causes a diamond rain phenomenon on both planets. In 2017, researchers managed to simulate the conditions that would cause diamonds to form in a lab, which supports the hypothesis that diamond rain occurs on Neptune and Uranus. First detected by Voyager 2 in 1989, Neptune's magnetic field is pretty wacky. The main axis of the field is tipped over by about 47 degrees compared with the rotation axis. In most planets, the magnetic field axis is at least close to symmetrical with the rotation axis. Because of the strange tilt, just like Uranus, Neptune's magnetosphere goes through wild changes with every rotation. In addition to the tilt, the magnetic field is also offset from Neptune's center by about 55% of the planet's radius. This means it's centered closer to the cloud tops than to the actual center of the planet. At 27 times the strength of Earth's, Neptune's magnetic field could be rooted in electrical currents flowing through its massive ocean of water, ammonia, and methane. Because of the high tilt of the magnetic field, the particles trapped in the magnetosphere are repeatedly swept past the orbits of Neptune's moons and rings. Many of these particles might be absorbed into the moons and ring materials. This empties the magnetosphere of a large portion of its charged particles, leading to Neptune's magnetosphere having fewer protons and electrons per unit of volume than the magnetosphere of any other giant planet. Near the magnetic poles, charged particles in the magnetosphere can travel along the magnetic field lines into the atmosphere. As the particles collide with the atmosphere's gases, they cause them to fluoresce, resulting in weak auroras. Neptune has 16 known moons, all named after various lesser sea gods and nymphs in Greek mythology. Neptune's largest moon, Triton, was discovered by William Lassell on October 10, 1846, just 17 days after the planet itself was discovered. Triton is the only spherical moon of Neptune. It's also the only large moon in the solar system that orbits its host planet in the retrograde direction, opposite of the planet's rotation. This suggests it may have once been an independent object that Neptune captured. Although Triton is extremely cold with surface temperatures of around negative 391 degrees Fahrenheit, Voyager 2 discovered geysers spewing icy material up to 5 miles off the surface. This shows that the interior appears to be warm. Triton's thin atmosphere, which was discovered by Voyager, has been detected from Earth several times since. It's growing warmer, but scientists don't know why. Scientists are also investigating the possibility of a subsurface ocean on the moon. In 2010, seasons were discovered on Triton. Neptune's gravity is also slowly dragging Triton closer to it. In millions of years, Triton will come close enough for the gravitational forces to rip it apart. In 2013, scientists working with SETI caught sight of Neptune's lost moon Naiad using data from the Hubble Space Telescope. This moon had remained unseen since its discovery in 1989 through the Voyager 2 images. Also in 2013, scientists using Hubble found a 14th moon. In February of this year, 2 more moons were announced, right alongside another moon for Uranus. Neptune's rings were discovered when astronomers observed them blocking the light from a star. Later, the rings were identified in images from Voyager 2. There are at least 5 main rings and 4 prominent ring arcs that we know of. Starting near the planet and moving outward, the main ring rings are named Galle, Leverrier, Lassell, Arago, and Adams. These rings are thought to be relatively young and short-lived. Earth-based observations have found that the rings are far more unstable than previously thought, and some are already dwindling away rapidly. Neptune's ring system has peculiar clumps of dust called arcs. 4 prominent arcs named Liberté, Égalité, Fraternité, and Courage are located in the outermost ring, Adams. These arcs are strange because the laws of motion dictate that they should spread out evenly rather than remaining clumped together. Scientists now think the gravitational effects of Galatea, a moon just inward from the ring, stabilizes the arcs and prevents them from spreading out. And there's Neptune. I know this one is pretty short, but there's really just not a whole lot to say, just like with Uranus. Neither planet has been thoroughly explored, and they're the only planets in the solar system that have never had a dedicated mission. I hope we get to learn more about them in the future, though. Next up will be a video about Neptune's moons, which should be pretty simple because there's only 16 of them, and we probably don't know much about any of them. So if you're interested in that, feel free to stick around. I don't really have much else to say here, except that I think Neptune is cool, but that's probably obvious. Thanks for watching, like and subscribe if you enjoyed, and have a good day.